Right, so I got the longest talk title you can see here. Right, so the key thing I want to call out is the design time and runtime. How many of us like that and hate that? And then at the same time, the CI/CD. That's a pain in the butt for every developer, right? It's a process somebody has to adhere to. In EDA, which is typically a black box, unless the architect who designed or the developer who coded comes and explains to you. But we want CI/CD there for good reasons. That was not possible before because there was no standard way of representing asynchronous service or an API. Async API came into picture and definitely made a difference. Now, the adoption has exploded in the past 2-3 years, right? So my topic is going to be on bridging this gap. What do I mean by that? As you go, you'll see. So this is a mission statement. We fully support that. Improve the current state of event-driven architectures, right? Everybody has event-driven architecture, starting from our original Kafka to the traditional MQs, and then some many products and services in the middle, and then this pure play EDA players, Confluent, Solace, Nats, and these giants. And each of them have 3 different versions of PubSub, some based on Kafka, some based on something else. So EDA is here to say, that means the asynchronous APIs and asynchronous services are integral part. The adoption is increasing, and as we see, we will have a coexisting ecosystem in volume and strength parallel to the open API, the REST APIs. So before I go, just quickly, what is EDA? It's a design pattern. Hari talked about it, Vaishnavi talked about it, in which the decoupled applications talk to each other, but asynchronously, right? So asynchronously meaning there is no coupling. How do they do? There is an intermediary called broker sitting in the middle that's mediating this interaction. And the interaction happens in the form of events. Sometimes you can also say messages. So here's the picture. What this does is kind of a shift from the traditional thinking where it's a point-to-point. The endpoint is down, you cannot even have a conversation. But with the broker in the middle, you can create an ecosystem living in different kind of environments. Your producers and consumers. See, we are moving away from the traditional requester, replier, client, and so on. So these producers and consumers can live in a public cloud or a private cloud or on-prem system, or even a kind of a wrapper around your traditional MQ JMS applications or legacy applications. So all of these guys can talk to each other, creating a cohesive, event-driven platform. Okay? So that's what EDA brings to the table. But what is lacking in an EDA? Rather, what EDA needs is ability to document your services that you created, right? And then generating code, because it's a nightmare. Unlike our open API where you have only one protocol, and typically JavaScript, Node.js, Java, whatever it is, standard. But here we are talking about MQTT, AMQP, JMS, REST, the HTTP, and then some proprietary protocols, and of course Kafka. Generating code against this plethora of options, Node.js kind of frameworks, and then these languages, Java, JavaScript, Kotlin, you know it. There's plenty of options. If you go to AsyncAPI tooling ecosystem web page, you'll be surprised how many templates exist. That's a proof to the statement that I'm making. As a product, as an EDA vendor, you have the obligation to support all these things. You cannot be coding everything by yourself. This kind of arrival of standards and maturity of standards makes a huge difference. And the third piece is about discovery. It's all about not building new applications. What if I have a TIBCO-based system that's doing something similar to EDA, rather asynchronous event exchange, or maybe a legacy MQ, and then I use Solace, Kafka. So I have a mixed mode of environment. How do I discover what exists in my system? Discovery is all about discovering the events. Only when you know what you have, you can be smarter in building newer things, right? And last but not least, event management. Asynchronous interaction is all about events, especially in the EDA. How do you manage them? This management is a kind of Uber word that covers governance and all the way to security, sharing, reuse, and so on. This becomes very specific to the individual product, right? Is there a standard? It's evolving, but rather it's getting unified with the traditional API management. But our focus is on the first 3, right? So in an EDA context, the journey goes like this. First, you talk to the stakeholders, gather the requirements, build a design, and then refine based on the feedback before even you put any single line of code into action. And then incrementally implement. This is a traditional model, right? And EDA is a great candidate for this incremental approach, right? I also call out this domain-driven design, where the notion of creating something as a domain object and creating a shared understanding, and then implementing it, continued refinement. That's exactly what this picture represents, and EDA follows this. But what it does is, there's a term, sorry, what we call is event storming. You bring in all the stakeholders, right? Producer, consumer, influencer of some form, today, tomorrow, business people, technical people, and then put them in one room, gather their requirements. It could be a huge list, but you start out with something basic, right? In this entire picture, what we are gaining is a domain model where a domain object, something that relevant to the business context, where all the stakeholders can understand, maybe the business terminology, all the way to the construct, what makes up the object. And this creates a loose coupling. No one person has an oversight on this object, right? And second thing is, the understanding that is derived from this exercise is your event. Underneath, the schema and the attributes that makes up this event, facilitating this exchange. So all the stakeholders can make sense of what is being captured in an event, what this event represents, what's the business context it carries, right? Last but not least, we are talking about EDA. At the end of the day, somebody is going to produce events, somebody is going to consume events. And the event flows through the broker, and the broker rules can also be tagged as a metadata in an event, right? So this is like a EDA kind of emulating or benefiting from the domain-driven design concepts. So these are all good. What am I talking about here? This is setting the stage. Now, SDLC is the kind of a very, very important notion in any enterprise. For a small company, when you start out with, there also you will have some process. Like, all your specs should be in Word, and all these things should be stored in a Google Drive, right? If you're an enterprise, this gets more complicated. We have processes. In fact, I would even go to the extent of, the people have put their blood and sweat to create a system, right? So you cannot come in and say, I'm using EDA, it's very hard to document. No, SDLC is equally important. But when you look at the EDA, it's a black box, literally. Without AsyncAPI, if somebody was asking, say, Kafka guys to document their service, they will produce a funny YAML file. If you ask a Solace guy, he will produce a JSON file. I'm just saying, right? So there is no standard. There is no cohesive approach to how to capture this information. Missing standard is always a danger when a segment is maturing. SDLC directly benefits from this arrival of standard, right? So what am I talking about? The assets that you create in an EDA perspective, it can be grouped into two buckets. The design time assets, when you're building an application, you want to see them in the context of your business relevance. I'm going to create a domain, which is a kind of a container of all the applications belonging to the domain. And at application level, I'm going to say what events can be published, what events can be subscribed, and so on. Last but not least, the schema, right? So pretty much, it kind of draws parallel to what we have in the API. And last but, the topics and queues are very specific to EDA, right? But from a runtime perspective, it is truly an EDA thing. You may have environments, staging, testing, production, and so on. And then this notion of event mesh where you create, it's not about a single broker communication anymore. Modern problems kind of requires multiple brokers to work together and create a mesh. Either you have a geographic coverage or cross-boundary business coverage, right? And then messaging service, that's your simple broker. Event management agent, so that you open up your whole event management activity for other people to tap into and give you full access, right? And this is what we are talking about. So the design time and runtime, they produce different set of assets, and the network of brokers creates the runtime. All these assets or the artifacts need to be managed. Now, in the absence of SDLC, we know the traditional issues that you would have. Incomplete requirements gathering, lack of documentation, limited adaptability. Pretty much you are black boxed into time, right? You cannot move out with these. Now, how about EDA? EDA kind of will aim from the same problems, but I want to call out only 4. First one is lack of governance of shared resources. In an enterprise level, anything that we say, the first question is, what's your governance strategy, right? Governance, 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 because it's an umbrella of so many vital things, from legal compliance to political compulsions to your company policies, right? So the lack of governance leads to chaos. We don't want to be in there. And EDA being uncontrollable to some extent, starting from visualization to topologies, and it can go any direction, right? So we need to have full good governance strategy and lack of visibility of existing events. I mean, event is the asset that you work so hard to create, right? If I have a service, say credit card verification, if another team wants it, why do they need to recreate that? It's just a matter of telling them, hey, there is a service, and this is the event that you publish, you get back a response, this is a response, right? So the visibility in some form, maybe as a catalog or maybe as a repository, registry, some form of the exposure is required. Otherwise, you'll end up in creating duplication and then the overhead that comes along with that, right? And third one is, again, about visibility. Organizationally, you are planning for future, right? You need to know where to invest, what to invest, not just infrastructure, everything, from dollars to effort and so on, right? You need to have a clear visibility, right? With this acquisition, am I going to redraw my infrastructure? Or can I do a offhand integration? I'm just giving a simple example, but it could be as complex as it's possible, right? So this impacts organizational planning. That means the business suite executives will not like your plan if it's not justified. And then the last but not least, the exposure of events is very critical for reuse and collaboration. So you got to expose them in some place that's accessible. I mean, Hari and you also refer to it as schema registry for schema level, event for event catalog, and IBM guys, Dale Lane has built this entire event catalog. But even before these things came into picture, Solace, what we did is we wanted to solve this problem. At least 4 years back, we started this. Our answer to this was that's when the AsyncAPI was coming into Solace Event Portal in combination with the AsyncAPI. What is Event Portal? It's pretty nifty one. Management tool that helps you to visualize, optimize, govern event flow across your distributed enterprise. It's like a long word, but the point is you can design, you can manage, and you can also govern the entire infrastructure about EDA, right? Design events, event-driven apps with built-in best practices. Discover catalog events from across the business. So ability to discover, you could have a Kafka broker, but still supports topics and events. You could have a RabbitMQ. How about we discover, bring them into one fold? So you become the centralized governance platform. That's our answer to this whole notion of event management, what we call as an event portal. Now this is done, how about exposing it, sharing it with others? That's where the AsyncAPI comes in. AsyncAPI did a lot more than this. When I take a service, in our case, we say application or an event API. I would love to talk more on the event API, but it'll take us to a tangent. So anything that you build as an event, there is no value in a single event. It is valuable only in the context of an application. Application can publish these events, can subscribe to these events. So you are bringing in the governance and security policies, all those things put together, you got an instance, what you call as an application. Now the application can be exported as AsyncAPI. Now you are sharing an event-driven flow as an API. And AsyncAPI comes into picture in documenting that beautifully. That's the major benefit from an event flow perspective. But beyond that, this event management portal, where these tools for designing, governing, and managing exist, they open up APIs that helps you to collaborate with your SDLC tools today. Tell me how many of us don't use Slack. Tell me how many of us don't use Confluence, right? And all the way to IntelliJ plugin, GitHub integration, CI/CD, Jenkins. You can see here there's a lot more. So these plugins automatically allow you to discover things on the event portal. Now you're not just talking about EDA at runtime, you're talking about EDA at design time. So you can collaborate, you can document anything that you would have in a typical SDLC requirement, right? So all these things are possible, and AsyncAPI makes a huge difference in this case, not just about the runtime, right? Now, to demonstrate this, I have a simple example. So in a real-world scenario, you start out with the design time. That means you draw the box, or whatever you do, you build your design, right? And then you generate code, and then put it in a GitHub, right? And then continue to work on it. The GitHub code changes, and you continue to check in, PR process, merge, approval, the whole 9 yards. And then, at that point in time, you should be seeing that your design has changed. Because code is in phase 2, your design document is in still phase 1. How do you keep them in sync, right? Now, this is where the documentation capability comes in. If you can generate the documentation, the standards-based documentation from your code, that can become an asset that can be pushed to the design portal, right? In the real world, is it supported? Typically not. But is it not happening? 100% it's happening. We reverse engineer the code to update the design document. In our case, we have a design resides in the event portal, right? In the form of application, event, schema, and so on. That's where we start out with. So let me quickly jump into this demo. It's a very small one. I'm not going to run the demo. I will talk about thank you. Okay, this is the event portal. As I mentioned, right, this is a designer tool where you create an application domain. Under this domain, you can have one or more applications. In this case, I have 4 applications. And if I drill down, in this domain, I have this many number of events. And what you see here is a topic, right? The topic is hierarchical, carrying a contextual reference to the data or the event origin. So this can be used for filtering and routing and so on. And then the schema is referred by this. So you can see pretty much, anything and everything related to your EDA, basically your assets. And last but not least, this is the one that you will expose to the world. Your asynchronous interactions are exposed to the world as event APIs. You can also use the term asynchronous API, but what we say is event API, right? So if you look at this one, of course, with the portal comes the responsibility of state management, version management, all those things. I'm not going to go into that one. You can see here, this event API is permitted to publish one event basket on this topic, version 1, right? So what I'm going to do is, I'm going to generate this AsyncAPI document. So download AsyncAPI document. I'm going to show you the file. Unfortunately, if I run it, it'll take a little bit of time, right? So here it is. So this is my AsyncAPI document for the basket service, right? So as many of you showed in the morning, right, there's a schema, and then there's a message called basket. It operates on this topic. Retail, Acme, online. This is a topic on which the interaction will happen. And this is the definition of the service, right? And AsyncAPI 2.5, a lot of metadata. One of the good things about AsyncAPI that I personally like is they provide facility for you to capture custom data, custom attributes. So all these things, X-EP is all Solace specific, right? So anything that I have to do in terms of code generation or reverse coding, I can build my own template. So with this, I put through the AG command, I generate the code, and the code looks like this. Standard code generated, only the scaffolding is what you get, right? I added this method to publish this basket event every 10 seconds, or every 5 seconds, and then it's just publishing a simple event. And this is Spring Cloud Stream application, right? This works just fine. But then I realized, oh my God, I need to generate some risky basket event if the quantity goes above some number. It's a minor change, right? I made the code change. Just a second. Here it is. So I check the quantity. If it is greater than 5, I publish this event. Now, this event doesn't exist in our design event portal. But I'm able to update this AsyncAPI document. I continue to rely on the schema basket because that's reused. And I create a new event or message called risky basket, right? Payload reference, all those things are populated. This can be automated, right? There can be a binder or plugin that can go through the code and generate this AsyncAPI document, but it's not there yet. So AsyncAPI document is updated with the desired changes or the changes found in the code. Now, what do I do as a good citizen? I make the change, I check it in. In best practice, you would create a branch, put it in that branch, and then create a PR, somebody reviews it, right? So if each of these checkpoints allows us to vet the validity. What do I mean by that? Let me go to the code here. See, this is my basic repository. I have this source, everything is in there. And I created a couple workflows, couple of things. First one is Solace validate async YAML. Incoming async API document, validate it. Make sure that it's correct. That's a one check. Second thing is, if it is valid, see if the file is found in the existing repository with the same name. That's a second check. If it is found, do a diff. If it is found to be different, import it to the event portal. See the 4 checks? Now, with that, assuming that I've already shown you this one, I have a branch, feature branch, and I can show you the pull request. Pull request was, I checked in the changes, and no issues because the updated JSON, updated as AsyncAPI document was valid, and it was found to be different. So I wanted the workflow to do the import part, so I merged it, confirmed the merge. Let me show you the workflow here. The first one, when I populated the code, it did a check for presence of AsyncAPI document, right? AsyncAPI file found, but there is nothing to compare. So there is no follow-up needed. So that's the first commit. Second one, I checked in the code into the feature branch, and it goes through this document. Let me show you. AsyncAPI document present and validated it. If it was invalid, now your PR would have shown that result. Hey, there is an issue with your AsyncAPI document. Do not merge. You can, basically it's a checkpoint. You can follow up with other things if needed, right? Now, when I approved that pull request, it did 2 things. AsyncAPI document present and import it, right? For the sake of it, I'm just going to run this. Now I showed you here, there's only one event API version, and there's one application version, right? You can see here only one version. And the events, there is no risky basket, only basket is found. All I'm going to do is, just for the sake of it, I'm going to rerun this job. Hopefully. So this is a standard Git process. There's no magic about us doing anything. Check out the code, do a diff if it's found. The only thing is we have written this EP importer. Basically from the async API, parse it, identify the channels which translates to, in our case, topics or events, and schema, do the appropriate mapping and call our corresponding REST APIs, which I mentioned. Event portal has a REST API interface. You can create and manage these options, right? So that's precisely what's been done. So it's you can see here, just standard Git workflow. Hope it should not take too much time. Let's see. So the point I want to highlight with this exercise is async API goes farther than what you can imagine. We really appreciate, first, ability to standardize and document this, right? So the reuse and sharing, all those things are addressed. And next thing is, we can tap into this kind of a written form. You can update the async API document and then check it in, update your design, or go full direction. Right? This is done. Let me go to the next one. It should not take much time. See, behind the scene, it's parsing the async API document, find what version it is, all those things. Okay, it's done. Now let me go here and do a quick refresh. You can see here, since the application context got updated with the new event and so on, automatically a new version is created. And this new version, there are 2 events now the version is able to handle. One is basket and risky basket. There are 2 events, right? And if I go to events, you should be able to see the new event that got created. If you go here, the first version, and then it uses this schema basket, right? Now, the next stop for me is event API. This is the event API. The first version used just the pub of the basket event. But the second version, based on my change that I pushed in, now it will be able to publish 2 events. That's all it is. Now you expose this version as a async API document, now the reuse game starts, right? So this is just a small use case. We found it very interesting, and there are a few customers who are already putting this in use, right? That's it, guys. It's from a architect/developer perspective, it's an interesting use case. Async API serves a different use case, not just about the document and the code generation. Anyway, I'm done. If you have questions, feel free, please.
Do we have questions? 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 Okay, it seems like we don't have any questions.
They're very friendly to me.
Yes, thank you so much, Giri.